So when you're adding and subtracting rational expressions, I told you guys last week, rational expressions is just an algebraic, a fancier word for fractions. It's got a numerator, it's got a denominator. So really, we're just adding and subtracting fractions. The first two problems I took out of an elementary school book. The reason I did that was because to show you that the steps you use for 1A and 1B are exactly the same as the steps we're going to use today. So those same steps, they might look a little different because it's a different level, but it's essentially the same thing. Okay? Okay, so 1A. When we're subtracting or adding fractions, what's the first thing we gotta be aware of? Common denominators, right? We can't add or subtract fractions if their denominators are different. Okay? So the denominator for the first one is 15, and the denominator for the second one is 5. 1 second. So we can't add or subtract yet until the denominators are the same. So how do we make the denominators the same? A lot of you can do this in your head because you've been doing it for so long. I think fifth grade is when you start with fractions, or fourth grade or third grade you start with fractions. I think fourth and fifth is when you actually start adding them. Okay. So a lot of you can do the common denominators in your head. Great. That's great. You might not be able to do it today. So I'm going to show you how to do it so that you can do it. Okay, so first thing is factor. Factor the denominators. Okay. We done back there? Thank you. Okay. 15. If I was to do a tree for 15, what would I end up with? What numbers would I have circled? 5 and 3. So that's what I'm going to write down here. 5 times 3. If I did this, if I was to do the same thing, but for 5, what would I end up with? Just 5, right? Because it's 5 times 1. That's the first step. Second step is common denominator, what's missing? The first guy. It's got a 5 times 3. Is this guy missing anything that the other guy has? This guy's got a 3. It's not missing anything, right? In fact, it has more, right? So let's go to the other guy. Is the other guy missing something? So we have to make them the same. So to do that, we use multiplication, right? We don't use addition. We don't use subtraction. We use multiplication. To make them the same, we include it, right? But whatever we do to the bottom, we also have to do to the top. So that's why I have a times 3 and a times 3. So now, what's the common denominator? 15, right? Which a lot of you already knew that. You guys can look at those and see it. So the bottom is the same. 5 times 3, 5 times 3, 15. So now let's look at the top. We're done with the bottom. I have a 4 here. 4 is just 4, so I'm going to write 4. Minus 1 times 3. 3. Add or subtract now. 4 minus 3 is 1 over 15. Reduce if you can. I can't reduce that. 1 over 15 is reduced. You're done. Okay? That's a subtraction problem. You guys already know how to do that problem. That problem is not new. You guys know how to do that. Let's do another one that you know how to do. Okay. First thing, break down the denominators. If I was to do a factor tree for 3, what numbers would I circle? Just 3, 3, and 1, right? If I was to do the same thing for 7, what would I circle? Just 7, right? Okay, factor, that's the first step. Make them equal. Make them the same. What does this guy need? a 7, right? So I'm going to include a 7. So I don't add 7, I multiply times 7, right? Now, what does this guy need? Needs a 3. Common denominator, 7 times 3, or 3 times 7, which is 21 still. 1 times 7 is 7, plus 2 times 3, which is 6. Add the top. I don't think I can reduce 13 over 21. I'm done. Those steps that you did for A and B, you're going to do exactly the same thing. I'm not going to include any more steps. These are the same steps. Same steps. It's going to look a little different because you're not in 4th grade, 5th grade anymore, right? It's going to look a little different, but it's the same thing. It's exactly the same thing. Okay? All right, so let's look at 2A. Okay. We still got denominators. First step, break them down. So when I break down 5x to the 3rd power, well, first of all, if I were to do a factor tree for 5, what numbers would I circle? Just 5, because 5 can't break down, right? So it stays 5. How do I break down x to the 3rd? 3 times, right? X times x times x 3 times. Good. Now 2. Factor tree for 2, it'd be a short factor tree because it'd just be a 2, right? Step 1 done. Broke them down. Step 2, what's missing, what's needed? Okay. Let's start with the first guy. 5x, it's got a lot of stuff, but it's missing something. What is it missing that the other guy has? So I'm going to multiply by 2. The second guy is missing a lot. First things it's missing is a 5, and then 3 x's. So multiply the top by the same thing. Once you do that step, the denominator should be the same. The denominator should be the same. 2 times 5 is 10. 2 times 5 is 10. X times x times x is the same thing as x times x times x, x to the 3rd. So what is the common denominator? 10x to the 3rd, yep. Now let's do the top. 2 times 3 is 6, plus 1 times 5 is 5, x to the 3rd power. That was step 3. Now, step 4, if needed. So step 4 you might not do sometimes. So I'm going to ask you a question here, because I see this a lot. And I want to make sure that we're on the same page. You've seen this last week. Can I do this? They're both x to the 3rd. Can I just cancel them out?
No.
Yeah, there's something wrong about that, right? What's wrong about it? The bottom is a monomial, single guy by himself. The guy on the bottom is a lone wolf by himself, single guy. The top is not. The top is a binomial, right? It's got a connector. Connectors are pluses and minuses. Because of that plus, it's a binomial. Now, if it was like that, go for it. They're both monomials. But that's not the case. So we can't cancel anything out here. The only time you can cancel things out like that, where everything can be divided by the same thing. So let's say, I'll give you an example. Let's say this guy had an x. 6x, 5x to the third, 10x to the third. They all have x's, right? If they all have x's, then you can divide them all by x. But the 6 doesn't, so I can't. I'm done. Okay. All right. Okay, let's do B now. Subtracting two fractions. Nothing different. Got the first guy, we got the second guy. We're going to break down the first guy, and I'm going to break down the second guy. So 25 on the board, I actually broke down 25. It ends with 5 times 5. And then x times x. 5, again, small tree, because it's just a 5. What's needed, what's missing? Got to make them both the same. The first guy's got 2 5s and 2 x's. This guy's only got 1 5. So I need to include another 5 here and 2 more x's here. Whatever I do to the bottom, I have to do to the top. When I do that, are the bottoms both the same? Yeah, that's the common denominator. When the bottoms are the same, you got your common denominator. Because sometimes they won't even ask you. They'll just give you 2 fractions and they'll say, what's the common denominator? Then you don't even have to do step 3 or 4. We do for this one, but sometimes depending on the question. So we have 5 times x times x, 25x squared. The first one, I didn't multiply anything times. Minus. The second one I did. 1 times 5 is 5x squared. See a 5 and a 25 and an x squared and an x squared. Sometimes you want to do that. Sometimes you want to say, oh, divide by 5, divide by 5. Can't do those things on this one. Because the top is a binomial and the 1 doesn't have an x. Can't be divided by 5. So we got to leave it. We got to leave it. Okay. That's essentially what we're doing. I gave you some more practice problems so that you could practice and see different problems. But essentially, that's what it is. Okay? Tiana, you're supposed to be doing that? Okay, thank you. Okay, so let's go to the back. Okay, so adding 2 fractions. The only difference with this one and the ones you've seen before is this got more letters. Big deal. You're still doing step 1. Break down the denominators. So the only difference with letters is you don't need to do the factor tree. I have x times x and y times y times y. Over here, I have x times y. What's missing? So the first guy, he's got 2 x's and 3 y's. So the second guy has just 2 x's and 1 y. Yeah, the next guy, the second guy, needs 2 more y's. So the common denominator, because they're both the same now, is x squared, y to the third. The top, 1 plus 1y squared. Again, that 1 here, that 1 in the front doesn't have a y. It's connected. These two guys are connected. So for me to cancel out anything, both of these guys have to have the same thing as this guy down here. And they don't. Done. Okay. All right, letter A, 3A. Now, the reason we do step one is to get a common denominator. Do these guys already have a common denominator? They're exactly the same. There's no difference. Now, if they already have a common denominator, why do we don't have to do step one? Step one is only done so that we can get a common denominator. They've already got one. So we don't have to do step one. We can jump right to step three. The common denominator is 4x plus 9. The top is negative 3x squared minus a negative 4x squared. Okay. Simplify or reduce if you can. I can simplify the top. Well, first of all, it's minus a negative, so that's going to be double negative. Double negative makes positive. Can I add them together? Can I add, are these guys, in other words, am I saying, are they like terms? Yeah, they are like terms, right? So I can add negative 3 plus 4, and I get positive 1x squared over 4x plus 9.
Would you quickly scroll back up real quick to
Sure. The one report?
Yeah. So you left it as 1 plus 1?
Yeah, because I didn't change that one. That one up here, the first one I didn't change because it already had everything that it needed.
So if that's the case, you just don't add to it?
Yeah, they're like, so a 1 doesn't have a y squared, so I can't add them. These guys, they were both x squared, so I could add them.
Got it.
If they're like terms, combine them. If they're not, don't. Yep. Okay, letter B, right below it. Subtracting. If I was to do a number tree for 6, or a factor tree, sorry, if I was to do a factor tree for 6, what numbers would I have circled? 3 and 2. And then this one's got an x with it. If I was to do a number tree or a factor tree for 8, I would circle 3 numbers. All 2s, yep, 2, 2, and 2. Step 1 is done. Step 2, what do they need to be the same? Well, the second guy has 3 2s. The first guy's only got 1. So I need to include 2 more. Do the same to the top. The second guy doesn't have a 3. So I have to include a 3. Now I know they're in different order, but do they multiply to be the same thing? Both denominators? 2 times 2 times 3 times 2. Let's see, 4 times 6 is 24. 3 times 2 is 6 times 4, 24. So they both make 24x. That's when you know you're done with the denominators, when they're both the same. Okay. So 2 times 2 is 4, times 7 is 28, minus 3 times 3 is 9. The top are like terms. So you can either add them or subtract them. 28 minus 9 is 19. I can't reduce them because 19 and 24 don't share anything besides 1. So you're done. Okay. All right. Try number 5, or letter C. Letter C at the top. Try this guy. This one's an addition. Okay, so the first one is 4. That's 2 times 2 times x. The next guy is close. Very close, but they're not the same. It's got 2 x's. So I got to include another x up here. The other guy's okay. So the common denominator is 4x squared. And then I have 7x plus 5, which I can't add to make 12 because they're not like terms. I'm done. Try letter D. If you haven't already started, try letter D right underneath. It's another addition problem. So the common denominator is 9. And then you're going to have 4x plus 21. Can't add those two guys together because they're not like terms, 4x and 21. You're done. Okay. We got one more that we have on this paper, and then I'm going to give you one more to do after that, and we're done. So we're going to finish early today. Today's I picked a lighter lesson for today because it was a 3-day weekend, so we'll be done after this. So we're this problem and then one more. So I think you're missing the second Y up there. Check your problem, check your letter E, and check my letter E. I think you're missing the second Y up there. So if you are, put that Y up there. Match yours to mine. Okay, how is this one different than the ones we've been doing all day so far? Second one isn't a fraction, has no denominator, right? How do we fix that? Put it over 1, yeah. If a number doesn't have a fraction, give it a fraction. Put a 1 underneath it. So how are we going to change? How is this problem going to be different? It's not. Once you give it that, you're going to do the same thing you've been doing since the beginning of today. This one's going to have y times y times y, and this guy just has an old-fashioned 1. Make them the same. So the second guy needs 3 y's. Is the first guy missing anything? A 1, right? Does it matter if I put the 1 there? If I multiply times 1, does it change anything? No. So if you want to put the 1 there, go for it. It doesn't change anything, but you don't need it. Okay, so let's see what I got. My denominators are now the same. 1 times y times y times y to the third. Okay. The first guy, 1 times x times y is just xy. Minus. What is x times y times y times y times y? xy4. Yep, xy to the fourth. Now the top is not like terms because they're close, but one has to the fourth power. If this one was to the fourth power, I would say add, subtract their coefficients, but they don't. But I have two terms on top, right? Binomial on top and a monomial on bottom. What do they all share in common? They all have a y. So this is when we need to do the last step. So how do we do it? This is how you do it. Right now, the top is a binomial. What does it have in common? What does the top have in common? A y. So I'm going to factor it. I'm going to factor out a y. GCF. Y is the GCF. So when I do that, no more y here, and y loses a power here. It's reverse distributive property. So if I was to do distributive property here, I'd get that. Now the bottom is going to stay the same. So why did I do that? Because now the GCF is a monomial now. It can cancel out with the other monomial there. So if I cancel them out, the y on top goes away or becomes a 1. I shouldn't say goes away. It becomes a 1. The bottom loses a power. So now you have x minus xy to the third over y squared. I'm going to give you one more problem to do. You don't have to do it on page 30. There's room underneath here, so you can do it on the paper. It's letter F. I'll pass out some tape right now. Letter F.
Really good.
Yeah, go ahead. Yeah, just leave it right there. Go ahead. Yeah, go ahead. I'll stamp it right now. So the bottom, common denominator, break them down, make them the same. So on top, I get 1 minus y to the third. On the bottom, I get y squared. I can't do what I did on the last problem because this one has no y. If there was a y there, then you could do what we did on the last problem, but that one doesn't have a y. So I can't really do anything. Done. Okay.